Welcome all of you. Myself Sunita Bharadi. Today I have to discuss about unit number 3rd IR spectroscopy from paper number 10 organic chemistry. IR spectroscopy. In last lecture we have to discuss about fundamental modes of vibrations. In that stretching vibrations and bending vibration we have to study and its sub points. That is very most important point to your examination. Okay, then today we have to discuss about the point selection rule in IR spectroscopy. Selection rule shows which vibration give IR absorption and which do not. The selection rule determine a particular vibration would be infrared active or not. So in this point, most important point is only non-centrosymmetrical vibrations are IR active. See here, only non-centrosymmetrical vibrations are IR active. Then see one by one which are IR active or which are IR inactive. First point is IR active transitions. What is meant by IR active transitions? Vibrations that causes change in dipole moments. What? Vibrations that causes change in dipole moments are IR active transition. For example, polar bond vibration. In last lecture we have to study what is meant by polar bond vibrations like CH, OH, NH, CO, etc. These are the polar bond molecules, means different molecule, different charges is called polar bond vibrations, means IR active transitions. It causes change in dipole moments are IR active transition. Then second point is IR inactive transitions. Vibrations that do not causes change in dipole moment are IR inactive transitions. IR inactive transitions, it does not change in dipole moment are IR inactive transitions. For example, non-polar bond vibrations. Non-polar bond vibration means same molecule, same charges like N2, H2, Cl2, etc. These are IR inactive transition. IR active transition, it causes change in dipole moment. IR inactive transition, it does not causes change in dipole moments. Then third point is allowed transition. What is allowed transition? In allowed transition, V0 to V1, V1 to V2, etc. transitions vibrations are fundamental transitions that gives intense IR band. Intense IR band means strong IR bands. So see here in structure, +1, -1, V0, V1, V2 like V5. So first we study +1. +1 means energy absorb केले जाते. +1 energy absorption, -1 energy release, energy reduce, energy emission. So first we study discuss in for +1. +1 means energy absorption. See here V0 arrow, V0 to V1, V1 to V2. डिफरन्स कितीचा आहे? +1. कितीचा आहे? +1चा. आणि लेफ्ट साईड राईट साईड V5 टू V4, V4 टू V3 लाईक V1 टू V0. एनर्जी रिड्यूस झाले म्हणजे डिफरन्स किती आहे? -1. एनर्जी ॲब्सॉर्प्शन +1, एनर्जी रिड्यूस, एनर्जी रिलीज -1. मग ह्या व्हायब्रेशनमध्ये ट्रान्झिशनमध्ये डिफरन्स कितीचा आहे, +1 किंवा -1. कितीचा आहे, +1 -1. मग अलाउड ट्रान्झिशनमध्ये काय सांगितले, V0 to V1, V1 to V2 एक्सेट्रा ट्रान्झिशन्स आर fundamental transitions that gives intense IR band. Intense IR band means it is strong IR bands. म्हणजे काय शो करतं, अलाउड ट्रान्झिशन इट इज IR ॲक्टिव्ह ट्रान्झिशन. जे व्हायब्रेशनमध्ये ट्रान्झिशनमध्ये +-1चा डिफरन्स असेल, हा से IR ॲक्टिव्ह ट्रान्झिशन असतो. इट इज कॉल्ड अलाउड ट्रान्झिशन. Then fourth point is forbidden transition. What is mean by forbidden transition? V0 to V2 or V0 to V3 gives overtone bands and weak IR bands. Here V0 to V2 or V0 to V3 gives overtone bands and weak IR bands. So here in structure, in left side V0 to V2, V0 to V3 डिफरन्स कितीचा आहे, +2 and +3. in right side V5 to V3, V5 to V2 डिफरन्स -2 आणि -3चा डिफरन्स. मग अलाउड ट्रान्झिशनमध्ये काय सांगितलं, अलाउड ट्रान्झिशन इट इज IR ॲक्टिव्ह. इन फॉरबिडन ट्रान्झिशन डिफरन्स कितीचा आहे, +2, +3 and -2, -3. It is called, it gives overtone bands and weak IR band. It shows weak IR bands and it is called IR inactive transition. Why IR inactive transition? Because IR active transition म्हणजेच काय, व्हायब्रेशनमध्ये ट्रान्झिशनमध्ये डिफरन्स कितीचा असला पाहिजे, +-1चा. कितीचा, +-1चा. मग ह्या फॉरबिडन ट्रान्झिशनमध्ये डिफरन्स किती आहे, +2, +3, -2, -3 आहे. सो इट इज IR inactive transition and it gives overtone bands and weak IR bands. During the absorption of energy, the molecule can change its V value. During the absorption of energy, the molecule can change its V value. V value means vibrational quantum number and its J value. J value means rotational quantum number. For IR spectroscopy, delta V is equal to +-1, delta J is equal to +-1. That is, only those transitions will be IR active for which both delta V and delta J are equal to +-1. म्हणजेच IR ॲक्टिव्ह केव्हा असतो, जेव्हा ट्रान्झिशनमध्ये व्हायब्रेशनमध्ये डिफरन्स कितीचा असला पाहिजे, +-1चा डिफरन्स असेल तरच तो IR ॲक्टिव्ह ट्रान्झिशन असेल. कळालं. दिस इज ओवरऑल द सिलेक्शन रूल इन IR spectroscopy. Then next point is Hooke's law. What is Hooke's law? It is also more important to your examination, so listen carefully. Hooke's law. See in structure, in first point, in diatomic molecule, diatomic means two atoms, two molecules. In diatomic molecules like masses of M1 and M2, in diatomic molecule vibrations are simple harmonic oscillatory. Vibrations are simple harmonic oscillatory and we can apply Hooke's law to these vibrations. So in structure, first diatomic molecule कंप्रेशन, दोन्ही ॲटम कसे झाले आहेत, दोन्ही मॉलिक्यूल कंप्रेस झालेले आहेत, तुमच्या दोन्ही लाईनच्या सेंटरला कंप्रेस झालेले आहेत. अँड सेकंड पॉईंट इज इक्विलिब्रियम. दोन्ही ॲटम दोन्ही लाईनच्या सेंटरला आहेत. कसे आहेत? सेंटरला लाईनवरती आहेत. इट इज कॉल्ड इक्विलिब्रियम. अँड थर्ड पॉईंट इज स्ट्रेचिंग. कोणतं? स्ट्रेचिंग. स्ट्रेच झाले दोन्ही ॲटम, दोन्ही मॉलिक्यूल स्ट्रेच झाले, सो इट इज कॉल्ड स्ट्रेचिंग. देन सेकंड पॉईंट इज Hooke's law. Restoring force F. Restoring force means F is directly proportional to the displacement x in opposite direction. See here, restoring force is directly proportional to the displacement in opposite direction. Opposite direction means sign कोणता असणार? मायनस, निगेटिव्ह sign. So here in relation F is directly proportional to minus x. Therefore F is equal to minus k into x. So what is meant by k? K is equal to force constant. K means force constant and it indicates bond strength. K काय indicates करतं? It indicates bond strength. When x is equal to 1, then F is equal to minus k. It is the second point. Restoring force is directly proportional to the displacement in opposite direction. F is equal to minus k. Then third point is, as per Hooke's law, vibrational frequency is proportional to square root of force constant. काय सांगितलं आहे बघा? As per Hooke's law, vibrational frequency is proportional to square root of force constant k, and inversely proportional to square root of reduced mass mu of molecule. Reduced mass means mu of molecule. Therefore mu is directly proportional to square root of k upon mu. Mu means it is called reduced mass is equal to m1 into m2 divided by m1 plus m2. That is nu is equal to 1 upon 2 pi into square root of k upon mu. In terms of wave number, nu bar is equal to 1 upon 2 pi c into square root of k upon mu, as 1 upon 2 pi c is equal to constant. काय कॉन्स्टंट घेतलं याच्यामध्ये? 1 upon 2 pi c, it is constant. Therefore nu bar is directly proportional to square root of k upon mu. काय सांगितलंय? Vibrational frequency is proportional to square root of force constant and inversely proportional to square root of reduced mass of molecule. This is the third point in Hooke's law. Then fourth point is, on the basis of Hooke's law, we can say it reduces mass. If reduces mass mu is constant, then high k value means force constant, high k value, then we get more strong bond. High k value, more strong bond, and we obtain more vibration, that is high centimeter inverse. High k value, more strong bond, more vibrations, high centimeter inverse. When low k value, we get weak bond and less vibration. Low k value, weak bond, and less vibration we obtain. This is the fourth point in Hooke's law. Then fifth point is, if force constant K is constant, force constant K is constant, then heavy atoms more reduced mass, heavy atoms more reduced mass, less vibration we obtain. Less vibrations means low centimeter inverse. When light atoms we get less reduced mass means mu, and we obtain more vibrations, that is high centimeter inverse. High atoms more reduced mass, less vibrations. When light atoms less reduced mass, more vibration. This is fifth point for constant force constant K is constant. Then sixth point is, we take one example, CH3COOH. CH3COOH means simple example, it is called acetic acid. So study we one by one. In this acetic acid, carbon double bond oxygen as double bond, it is more stronger. का आहे CO म्हणजे C डबल बॉन्ड O हा मोर स्ट्रॉंगर असेल, स्ट्रॉंगर बॉन्ड आहे, आणि मोर स्ट्रॉंगर बॉन्ड असेल तर हाय K व्हॅल्यू. हाय K व्हॅल्यू मीन्स फोर्स कॉन्स्टंट इज हाय, देन we get more absorption. More stronger bond, high K value, and we obtain more vibrations, and its CO, C double bond O, its IR range is 1730 centimeter inverse. Then second, carbon single bond oxygen, as single bond is less stronger. कसं असेल, single bond less stronger than low K value. Less stronger, low K value, less vibrations. More stronger, high K value, more vibrations. Less stronger, low K value, less vibrations in carbon single bond oxygen, and its IR range is 1250 centimeter inverse. Then next, third is oxygen OH bond, which OH bond, see here in example, OH bond, it is light atoms. OH bond, it is light atoms. When light atoms, we get low reduced mass and more vibrations. Light atoms, low reduced mass, more vibration, and its OH bond, it is a broad band. OH, it is a broad band, and its IR range is 3000 centimeter inverse. 3000 centimeter inverse. And last one is carbon single bond, it is heavy atoms. Carbon single bond is heavy atoms and high reduced mass. We get high reduced mass and obtain less vibrations. Heavy atoms, high reduced mass, less vibration, and its IR range is 1200 centimeter inverse. This is the example of acetic acid we have to discuss. Then next point is energy of vibration. What? Energy of vibration. The vibrations are always at specific quantities energy levels whose energy is given by following equation. Equation is EV is equal to in bracket v plus 1 upon 2h nu, where v is vibrational quantum number whose integral value can be 0, 1, 2, 3, etc. It is called energy of vibrations. Then next is energy between two vibrational level. What is energy between two vibrational level? Then first we see, by absorbing IR radiation, a molecule undergoes transition from lowest vibrational level. Lowest vibrational level means E0 and V is equal to 0 to succeeding level. Succeeding level means E1 and V is equal to 1. By a molecule can undergo transition from lowest vibrational level to succeeding level, the frequency of exciting radiation is given by the equation is nu is equal to E1 minus E0. Nu is equal to E1 minus E0 divided by H, and is generally molecular vibrations are not strictly harmonic. कसे असतात? Generally molecular vibrations are not strictly harmonic. Therefore, overtone bands are also seen and their frequency will be 2 nu, 3 nu, etc. This is the energy between two vibrational levels. Then last one is, the vibrational frequency increases as the bond strength means K value increases from carbon-carbon single bond to carbon-carbon triple bond, even though the reduced mass mu remains constant. जेव्हा रिड्यूस्ड मास कॉन्स्टंट असेल तेव्हा व्हायब्रेशनल फ्रिक्वेन्सी इन्क्रीजेस, बॉन्ड स्ट्रेंथ इन्क्रीजेस मीन्स कार्बन कार्बन सिंगल बॉन्ड टू कार्बन कार्बन ट्रिपल बॉन्ड, बॉन्ड स्ट्रेंथ कसे असेल? इन्क्रीजिंगली असेल. कसे असेल? इन्क्रीजिंगली. सो टाइप्स ऑफ बॉन्ड स्ट्रेंथ लाईक कार्बन कार्बन triple bond greater than carbon carbon, double bond greater than carbon carbon single bond. Then see here, carbon carbon single bond, it is strong. Carbon carbon double bond, it is stronger bond, and carbon carbon triple bond, it is a strongest bond. So it is increases. Carbon carbon single bond to carbon carbon triple bond increasing vibrational frequency. So carbon carbon single bond, its IR range is 1200 centimeter inverse. Carbon carbon double bond, its range is 1650 centimeter inverse, and carbon carbon triple bond is 2200 centimeter. This is the overall Hooke's law. Thank you.